Okay, I am just going to, we did this, right?
Yeah.
So there was a question by one of my top chemistry students, Lauren, okay, one of my top chemistry students, and she said, well, how do you know, will this be an absolute prediction as to whether or not the reaction will go? And that kind of idea was actually originated by another top chemistry student, Eden, okay? So, and I said, well, not necessarily. I've been kind of hedging. Wouldn't you say, Munkle, hedging? Well, and I said, well, you have to look at entropy and Gibbs free energy. Well, we could do this right now. We could do this right now and say, well, let's do the Gibbs free energy and see what happens. So what we're going to do is, we're going to look up propane, and we're going to see the Gibbs free energy of propane is negative 24. Is that okay? Negative 24 for propane, and it's per mole. Negative 24, and this is kilojoules per mole. Negative 24, and then, what else? And then carbon dioxide, is it on here? Carbon dioxide? I guess we can't really do it, can we? We don't have the other values. Do we have the other values for Gibbs free energy?
Yeah.
Where is it? Oh, there it is, carbon dioxide. So what do you have for the middle one, the Gibbs free energy, the delta G? Yeah, okay.
No, it's okay. It's okay.
Everybody's done that, you know, fiddling with your pen, all of a sudden you do something wrong and it shoots across the classroom, right? Okay. All right, so what is it for carbon dioxide? Per mole?
394.4.
394? Is that what you said?
Yeah, negative 394.
And that's for delta G? Yeah? 394, and what's water? Is water up there?
Oh,
Is it?
in liquid state.
Well, this says steam state, which is gas. Same idea. Negative 228.6. Is that right? We'll say negative 229. Is that all right? Yes? Is that okay? Are we all right with that? Okay. And then we're going to do this. This is just going to be, this is minus. This is minus a minus 24. Right? Let's just write this all out. So this is going to be 3 times 394. That's a negative. You know what? We'll make that clearer. 3 times negative 394, right? Plus 4 times 229. Again, I keep forgetting that negative. Okay? And then this is negative, right? So what's that value going to be? Anybody got it? Help me out here. What's 3 times 394, right?
Negative 1182.
Negative 1182. Is that what you said?
Yeah.
Ever since I was a kid, I cannot make 8s well. And really concentrate. All right, 1182. And what about?
That's negative 916.
Negative what?
916.
916. And then, and what do you get when you do that? What do you get?
Negative 2098.
Negative what?
2098.
And then plus 24. And what do you get? Negative, negative. What do you get? 2074. Is that right?
Yeah.
Right?
Yeah.
Negative. And what's that? Kilojoules? Just total kilojoules, right? Right? So is the reaction going to run? The rule is if the delta G is negative, the reaction will go. Not only will it will go vigorously, won't it? Because if the delta G is 0, then it's in equilibrium. You get that? If it's 0, 0, 0, it means that the reaction is at equilibrium.
This is delta G
No, Gibbs. Gibbs free energy. You got to read up on it. We'll talk about it. I just want to do a quick Gibbs, just to show you that if you have enthalpy, delta H, delta G, or delta S, entropy, it's the same process to find the change in that particular thermodynamic quantity. It's all very basic. It's not hard stuff. Clear? Okay? We're off. How you doing?
I fixed my hair, sir.
I want everybody to know at home that Lauren recovered successfully her pen. All right, let me tilt this down a little bit so you can get everything in there. Okay, good. I'll leave that on for a second. I got to hook up my battery, and we're all set. Okay? All right, that was good. That was a good one. Okay, here we go.